Fine, right? Yeah. Okay. So welcome to data discovery on Hadoop. And essentially, what we're trying to do here is share an approach that we have taken at Yahoo in terms of trying to maximize the value out of our data. So if you're a Hadoop-driven business or want to be a Hadoop-driven business, our hope is that this approach helps you think through some of the issues that we're facing and how we're solving those. Okay, so before we get started, let me introduce myself. My name is Sumeet Singh, and I'm a Senior Director of Product Management at Yahoo, and responsible for Hadoop products. And then my co-speaker is Thiruval Thirumulan, who's a Principal Engineer in the Hive team at Yahoo, and he works across Hive, Hive Server 2, and HCatalog. Okay, so let's get started. Before we dive deeper into the talk itself, let me outline an agenda of what we plan to cover here. So we'll talk about the data management challenge as we see it for Hadoop at Yahoo. We'll then talk about how Apache HCatalog solves a lot of those challenges. We'll get into how to get all your company's data into HCatalog, which is how we're trying to solve this data management challenge. And then we'll get into the specifics of discovery. Right? And as you get all your data into HCatalog, it becomes quite easy to actually open it up for ad hoc access to your entire company so that they can leverage or get the most out of that data. And then finally, we'll try and summarize and open it up for Q&A, perhaps until you get hungry or our microphones are shut down. Okay, so let's talk about what Hadoop at Yahoo looks like. So we have lots of products and properties that generate billions of events, to be precise, 120 billion events a day, right? And that data, all those events are of extreme value to us. So what we try to do is capture all that data into a common place that becomes the source of truth for all data at Yahoo, and that's the Hadoop grid. Right? So it's a shared multi-tenant environment where all data comes in. Right? We also pull data from a variety of different sources, social graphs through our partnerships. We crawl internet or get crawl content from elsewhere and other types of data. But the idea is that they all come together on the Hadoop grid. Okay? And then, of course, we process that data and then try and serve that or try to extract the value through Hadoop and serve that value back to our consumer in terms of personalized experiences throughout our products and properties. Right? So that's the essence of the data operations on Hadoop at Yahoo. And of course, you can do BI, reporting and analytics on top of the processed data. Right, so that's the context of what we're trying to solve. And as a result, as all this data starts to gather in one place, you actually need a scalable platform. And as you can see in our case, it has scaled pretty well. So the HDFS continues to grow at a pretty dramatic pace, or sort of even pace these days. But it's still quite dramatic. We're at 480 petabytes of HDFS if you combine all of Hadoop and HBase together. And so what's on that infrastructure? There are really 1.25 billion files and directories on that infrastructure. And this talk is really about what do you want to know about those files and directories, right? So you will be insane if you want to know about all of them. But if you want to know, you should have the ability to know about what these are, right, and what their properties are. So this talk is really about what those 1.25 billion files are. And then once you have all your data in HDFS, then you apply a variety of tools from the Hadoop ecosystem, like MapReduce, like Pig, or Hive, to process that data. Right? So they each have interaction paths with HDFS to process that data. Pig and MapReduce were the early ones, and then Hive was introduced, which introduced yet another component along with it, which is the Hive Metastore. Right? So that's what the lay of land looks like when you're processing all that data on HDFS. And then, of course, at Yahoo, we use Oozie a lot. I mean, I would say almost 60% of all the jobs that are scheduled on the grid are scheduled through Oozie. Right, so it's pretty important for us in terms of driving automation of jobs on the grid. Okay, HBase follows about the same story. There's a lot of data in HBase that is of interest across the company, and there are a variety of tools, each of these, that actually can interact with data in HBase, right? So through different mechanisms, essentially storage handlers. Okay, and then Oozie can also do about the same thing as it does for Hadoop. Okay? Just to put things in perspective, the different types of these tools that I described to you that are operating on that data on HDFS, there's a pretty good mix of jobs. We run roughly 26 million jobs every month as of last month. So this is a snapshot when the slides were due. As you can see, Pig, MapReduce, and Hive pretty much constitute a majority of the jobs that run on our platform. And as I said, Oozie is our primary scheduler for the grid, so you see a lot of Oozie launcher jobs as well in the mix, right? So a pretty wide variety of job distribution, wide set of tools that are operating on that 480 petabytes I described to you in HDFS. So what happens as a result of all the scale, as a result of a multi-tenant platform, data management becomes a challenge, right? But before we describe those challenges to you, let's try and understand what the data economy on the platform looks like. So we call a set of people data producers. And these are the people who are actually doing ETL on that events that I described to you, billions of them that are coming in, and are producing data on the platform, okay? And then there are consumers downstream who are actually consuming that data off of that platform, right? So that's sort of the data economy that's in play here. And that leads, this sort of data economy leads to a set of challenges that we're going to describe, which is the data essentially shared across a wide variety of tools, right? So that's your first challenge. The schema and semantics knowledge may or may not be brought across the organization, right? So both are important. And then schema evolution should be supported, so changes should be easy, and people should know about that the change happened, okay? And then access control should not always be all or nothing. It should be more fine-grained. Like either you grant access to data or you don't, I should have more finer-grained business rules-based access control that can be applied to that data. The ownership of that data should be clear. I should know who to talk to or who to contact if I have a question on that data from a platform perspective. Data lineage and integrity or data quality are also important, and I need to know about those. And then finally, I need to satisfy the audit and compliance requirements and eliminate any wasteful retention that's on HDFS because it costs. Although cost economics is what is taken care of from a Hadoop standpoint, at least for us at web scale, it's still important and it still costs millions of dollars, right? So those are the challenges, and we believe that our approach with Apache HCatalog, as well as data discovery, solves most of these challenges. And that's exactly what we're going to go through as to how it solves those challenges, right? So where does HCatalog sit in our platform tech stack or ecosystem? So it's at the storage layer. It stores all the metadata about the data, along with HDFS and HBase, which primarily store data, okay? And then the tools that I described to you, that's on the services layer, that's at the top, that's what the developers primarily work with in terms of processing and analyzing data. And then there are a variety of processing engines available, all pretty much running on Yarn, or close to running on Yarn, MapReduce, Tez, Storm, Spark, okay? So those are the 4 processing engines that we have that are playing on top of that data. All right, so how does HCatalog solve at least some of the challenges? And we'll go through one of them, one by one, through all of them. So let's start with what it does or what it is, right? So it opens up Hive Metastore. Since Hive introduced another component in the stack, it opens up that Metastore for broader access for Pig and MapReduce and other things, right? So it's essentially a wrapper around that Metastore. And Pig can then actually, or MapReduce, can use about the same types of abstractions that Hive uses, which is database, table, and partitions. And we'll talk and go to details about those. And then SERDI handles, so there's a single SERDI per record format, handles the serialization, deserialization, and in conjunction with storage handler, also lets you forget about the underlying stored format, the file format, as well as the storage details, right? So you solve 3 problems with HCatalog. You let the tools interoperate on the same data or share data, right? Now you have Pig, MapReduce, Hive, and all of the tools become aware of schema on HDFS, which was earlier encoded in the application. So you've solved for schema, you've solved for interoperability, Okay, that just by introducing HCatalog. And then, of course, Oozie works the same way to schedule those jobs right on top. So what is that data model, which I just talked about, the DB, the table, the partition. So DB is essentially an administrative boundary. All the projects for a BU or a project sort of lies in that namespace, okay? And then tables essentially are mimicking the data feeds or feeds that the project is producing or interested in processing. Okay? And then partitions are essentially the unit of data that you want to process. So say date, for example, like I want to process data every day. So the partition is the notion of all data that was generated that you're interested in for that day. Right? And then there are other facilities like skewed tables, where if you have a skewed data set, you can split those files for faster access, and you can create buckets or clusters of data, again, for faster access. So we're not going to get a lot into those, but we'll talk about DB, table, and partition a lot. Okay, so that's the data model HCat follows. And then, in terms of getting all the data that was in HDFS, at least from a legacy standpoint or backfill standpoint, these data sets can be registered into HCatalog, much the same way you create a table in Hive. Okay, so these are essentially, or in most cases, well, to start with, be external tables, because a lot of this data was, let's say, produced by Pig, but people want to consume it through Hive, right? So you don't want to sort of disturb what was there in HDFS, but get HCatalog to know about those. So you create a table, and you can manually add partitions to it, or you can automate that process as well. So we're going to talk about how to automate that process. Okay, and there are a variety of other ways to get data into HCatalog, like data manipulation language that you're familiar with. If you use Hive, it's very similar, or the data definition language, particularly as it comes to alter table add partitions, right? So you can load files, you can insert data into tables through select queries, or you can add partitions manually. Okay, so there are various ways to get data into HCatalog. Now, as I said now, Pig and MapReduce can also interact with HCatalog. So they follow the same thing with facilities like HCat Loader to read data and HCat Storer to write data. MapReduce does about the same thing with HCat input format and HCat output format, right? So now, as you can see, even MapReduce and Pig are working with the DB, table, and partition abstractions, right? So you no longer have the file locations, you no longer have the formats and other things, and the schema explicitly stated in your applications. So as things change, you don't have to go change your code or application. Okay, so it provides a really nice level of abstraction across all of these tools. And then I did talk about, well, it's tedious to add partitions, right? Particularly when talking about that scale, 480 petabytes, you don't want to do it yourself. So we have something called grid data management, which is a primary data lifecycle management tool at Yahoo. And what it does is every time you move a partition or a data feed into the grid, into the Hadoop, you actually talk to HCat Metastore. Right, so HCat Metastore has a table abstraction of the feed that you're trying to copy onto Hadoop. Right? And as you copy data in HDFS, you can actually call HCat Client API and add that partition in HCatalog. And HCatalog has this nice property that as partitions are added, it can trigger a notification to let everybody know that, hey, data, if it was daily, is available now, or data, if it was hourly, is available now. So it's all real time. Right? And if you're using the same tool to replicate data to other data centers, the other data centers can do about the same thing to let people consuming data in that data center off of HCatalog know that the data is available. Okay? Drop is about the same type of logistics. It's just that you call a different API to drop partition, you trigger the same notification, this data is no longer available, no longer retained. Okay? And let's talk a little bit about HCat notifications, because that's an important property of HCatalog through which automation is achieved. So HCatalog currently can trigger partitions notification for add and drop. Right? So it does it for database and tables as well. And other things can be added. As schema changes, it can notify that as well. So that's not there currently. But it's doable, right? So this is an example of a notification where a partition was added, HCatalog triggers the notification. Whosoever is interested in a publisher-subscriber type model with a messaging system, let's say like ActiveMQ, can subscribe to those messages, and say and get notified as the data becomes available and do whatever they want to do with that data. And so notifications is a nice property, and we do a lot with that. Say, for example, as I said, Oozie is our primary scheduler. What used to happen is that Oozie used to poll the name node all the time for data availability with a certain frequency. It was bad from at least two aspects. It would put pressure on the name node, as well as your worst case delay is at least the poll frequency, right? So you no longer have to do that, because as data gets available in HCatalog notifies it, Oozie becomes a consumer of those notifications, and if it's waiting on their data to trigger its workflow, it will start the workflow or resume processing as data becomes available, right? So what we have seen is that all the data lands up in one place, becomes of massive scale. At least in case of Yahoo, data management becomes a challenge, but you can get all your data in HCatalog, let all the tools share that data, and there's a nice property with HCatalog that can let you automate a lot of processing, right? With that, I'll invite Tiruval to talk about the specifics of data discovery.
So, so far we saw how do we bring data into HCatalog. Now, if you look at our cluster organization, we have one HCat instance per cluster, and if you look at all the HCat instances holistically, you get a single unified metadata view of all the data that's on our clusters. Now, that's powerful. Now, what can you do on top of that? You can actually build discovery tools that allow you to pick and choose a cluster and look at what datasets are available or what tables are available in that cluster. And you can also provide a search functionality which allows you to search for a dataset that you're looking for, and you know where your dataset is located. Now, what does this solve? What does a discovery tool solve? It basically gives you a single place to look at the schema of your dataset, right? And if your schema changes over time, you also go to the same discovery tool, and that gives you all the information. Lineage, you can actually figure out how datasets are actually interlinked, how they are created. We'll touch on it a little bit. Who owns the data, and if you walk up the lineage, you know who exactly the source of the data, whom should you talk to. And even on a production cluster, sometimes people experiment with the tables. You have temp tables, and then once they finalize all their pipelines, they go to production. So you can look at all that by using this discovery tool. Now, this is our overall organization. So you have multiple data centers, and like I said, you have one cluster, one HCat for each and every cluster. And we have a user portal within Yahoo for all our Hadoop customers to come on board to find what they're looking for. And this discovery tool will be a web application on that user portal. That portal will talk to all the HCatalog instances using Templeton a REST interface, a REST server. Now, people in the Hive community know it as Web HCatalog. So we are just using a subset of that. Now, what are the features we are planning to provide? Now, to start with, if you have access to one cluster, you can go to that cluster and look at what are the data sets available on it. So if you already have access to it, if you're already running your pipelines, and if additional data is available, you can join them, or you can use them to the best of your advantages. So you can basically look at the databases, browse the schema, look at how it's changed over time, look at the partitions, all those information. Now, again, search is another use case, and it provides a lot of advantages. In most cases, when Yahoo has a lot of startups, and if there is new data that is coming into Yahoo, people would like to find out where it is located. Say I would like to just go and search in the discovery tool about Tumblr, Aviate, all the acquisitions that we have made. And if it is available on any of the clusters, so the tool is basically going to pop up a list of clusters and where all the data is available. Now, so you can basically search for table name, comments, and stuff like that. Now, another use case is, you can take the example of a paranoid or, the security team. They would like to look at all the data sets which have, say, cookie information, and they would like to ensure the data that is behind it on HDFS has the right permissions. It doesn't have world readable, world writable, whatever it is. Different people can read it. So that is another use case. And when we're actually rolling out new versions of Hive, so we just moved from Hive 10 to Hive 12, and Hive 12 has org file format. And we would like to go and look at all the people, all the consumers who are using text file format or sequence file format, and we would like to convert them into org file format. Org file is pretty fast. So it helps us to do that, to do that mining. It also helps to find the information. So if there is one team which produces all the audience data across Yahoo, we would like to know what are all the data sets that particular team produces. So all of them will together make a single sense. And if there is any user who's running a big pipeline and they would like to move to HCatalog, so how can we help them? So currently they use a HDFS location and they run their pick scripts. All that they have to do is they have to copy their pick script, put it on the discovery tool. It'll basically bring up the table name or the database name that they have to look at. As simple as that. And like I mentioned before, you can also use the properties in the table, and you can basically tag it and make a lot of sense out of it. So this is the mock-up UI that we have. It pretty much has everything that I mentioned before. So if you look at the top, you actually have the search interface. So our intention is to build a search interface pretty similar to what a web search provides. So you can say file type PDF and search for something, and you get all the PDFs. So in a similar fashion, you can say cluster ABC and search for a Flickr, and then you get all the data sets that correspond to Flickr. In a similar fashion, you can say file format, owner. You can do all sorts of stuff like that. And the next thing on the left-hand side is the browsing use case that we spoke about. So it'll basically be a drop-down of all the clusters that we have. And once you click on it, you'll get a list of databases. In our case, we just have Flickr, Advertisement Data House, Audience, and all that. And on the right pane, you basically have all the results either from the browsing history or if it's a result of a search. So this is a table display. So once you click on a particular table, you get the basic table details. What are the column information, how people have described the column, and what are the partitions available, whom should you talk to if you need anything about the data set and all that. So if you look back, you'll see schema knowledge across all data sets at one place. So this gives you all that. Now, what's the design approach? Now, if you look at it, this is basically going to be a single web interface. And because it's a web interface and HCatalog runs Thrift interface, now we just need a plumbing in the middle. Now, this web application that we have, the user portal that we have, already supports the authentication that we provide within the company. Now, since it's a web interface, it's very easy for us to plug in our authentication mechanism to Templeton, which is Web HCat, and then deploy it along with each and every HCatalog instance. Now, we just picked up a part of the Web HCat interface, which is only the read-only metadata APIs, because it's going to be a read-only API, read-only interface pretty much. And since we actually capture which user logged in, which user is browsing or searching, we basically audit all the information. And wherever ACLs apply, we restrict the information that we show to the user. So this way, paranoid or security team, they don't have to panic. Now, with respect to search functionality, not much is available in HCatalog. There are very basic interfaces available, but it's not sufficient for what we're trying to do. So we are going to add new interfaces to HCatalog to support search. It'll basically be returning a list of search results and with annotated information, what matched, what didn't match, stuff like that. And here also we audit everything, ACL supply and stuff like that. For the short term, we're just going to build in the discovery and our production pipelines on the same instances. But if the load gets too high, we can actually split it out. So going forward, we are looking at 3 different things, right? So given a table, I would like to know how the table was produced. What are its source data sets? And given a table, I would like to understand the data sets which were derived from it. And I would also like to know how a data set changed over a period of time, change log of a data set. Now, we are still working on this, so this will help us in a lot of ways. See. So if you look at Lineage in general, right, you can look at it in 2 perspectives. 1 at a data entity level, 2 at a workflow level. The diagram that we have here is at the data entity level. So someone brings in data from external side, and they put it as an external table, and it's converted into an org table, and with that, a producer's job might get over. Now a second consumer comes in, he's an intermediate consumer, and he consumes the data from arc table, joins it against a table, a dimension table in HBase, and produces an intermediate statistics table on a hourly basis or something. And then a third consumer comes in and he produces daily stats table based on it. Now, if you actually start using Hive statistics, you have the row count information on each and every table on each and every partition. Now that helps anyone to go back and trace the lineage and then see if you have a spike in your data on a particular day, you can go back and see where it changed, what's the source, whom to talk to. If you add workflow related information to it, so from table 1, which is an external table, to arc table, a particular Oozie coordinator or Oozie workflow was used. If you start tagging all those graphs or all those directed graphs with workflow information, you'll basically figure out where is your bottleneck. And if you want your data faster, you know whom to talk to. This is still being worked upon. And the next thing is the change log of a data set. How has the data set changed over time? If you're consuming a data set and if your job completes much faster, maybe the data set is being compressed. You can go and look at the table and then see whether our compression was enabled, whether a particular column was deprecated and multiple columns were added. All of that in one single place. So at this point, I would like to give it back to Sumeet.
Thank you, Thiruval. All right, so you have all your data in one place. You can now know about it or discover it. The next logical step is to open that up so that everybody can benefit from it, right? So HCatalog is part of a broader solution set where you have Hive, Hive Server 2, and something called a Starling that I'll talk about. And these four sort of together solve a lot of these challenges that I was describing. Hive everybody knows about, so now I'm going to touch upon that. Just the way to actually issue SQL-like queries on Hadoop. Hive Server 2 essentially allows you to have concurrent client sessions using ODBC, JDBC to interact with all that data stored in HCatalog. HCatalog, we talked at length, and Starling essentially is a log warehouse built on exact same principles of Hive, HCatalog, and Oozie. And the idea here is that you have historical information about everything that happened as far as jobs are concerned. So all the job numbers and other things I showed you essentially comes from there. So it's really nice, allows us to have really good abilities to actually tell what's going on with the platform. And if you were to wonder what the deployment looks like physically in the data center, you have these four pieces that I talked to you about, right? So on the bottom left, you have the good old Hadoop grid. And on top, you have Hive Server installed, so all behind a load balancer, and essentially a variety of tools like BI tools and other JDBC clients can connect to concurrently to the data that is stored in Hive and can issue queries or jobs via Hive. Hive is the client that runs on launchers or gateways, so pretty standard. And then HCatalog itself is its own install behind, which is the metastore. And then the database, the actual DB, is usually a SQL database, which is also HA. And then all that is integrated into the cloud messaging so that you can exchange messages seamlessly. All right, so that's what it looks like in a data center, those four components from a solution standpoint. And what you essentially do to open it up is that one of the most favorite ways people consume now data off of platform that is produced in HCatalog is via Hive. And Hive now actually serves interactive queries through a range of improvements that have gone into version 11, 12, and 13 that really dramatically speeds up queries for our users. So if you will to talk about specific improvements that have gone in, it now uses TES as a generic DAG engine, uses vectorization where you fetch rows instead of single row operations at a time. There is cost-based optimization work going on that will use table and column level statistics to speed up queries. There are all kinds of other improvements, right? So there's a better columnar store, which is already saving us a lot of storage space because it compresses much better than RC file, which is ORC. And there are ready-to-use containers in the form of test services, which again has the same effect of speeding up queries, right? So opening up that data for both batch and interactive use cases now is pretty easy because you have all your data in one place. And then Hive Server 2, which is the second component I was describing as to how you open up this data, is again sort of a gateway for client sessions or concurrent sessions into the Hadoop grid. And then that actually, again, has nice properties because a lot of standard tools talk ODBC, JDBC, right? So if you were to open up the infrastructure that way, what I actually call it as something D2D, because product managers love to coin terms. So I call it data to desktop or big data to desktop. I don't know what you want to call it, but essentially any standard tool that can talk ODBC, JDBC can now directly consume that data. So either you want to visualize that data or you want to build reports using SQL. All that is pretty possible because you have all that data gathered together in one place in HCatalog, right? And then we have yet another tool called Data Out, which uses the JDBC connection. And the rationale behind doing something like this is that there are a lot of people who want to pull data out at periodic intervals. You've seen a lot of solutions to bring data in, and there are very few solutions to actually really pull data out of Hive or HCatalog. And this is one of those solutions where the client wrappers around JDBC produces splits for the data, assigns it to slaves, and then the slaves go pull those data in parallel one by one. Okay? So it really is useful for cases where you have strict SLAs in terms of getting data out that are of variable volume, or sometimes can even be on an ad hoc basis. Okay? And then finally, we talked a lot about opening it up with controlled access or fine-grained access, and there's a lot of work going on in the Hive team. So a lot of work has gone into Hive 13, where security has gotten a complete revamp, and it's completely possible now, in conjunction with views, to give people access at the column or row level, and really not do this all or nothing type philosophy like, hey, this is a finance data, you can't access it. Or it's a finance table, right? You can now restrict the revenue column, say, if you don't want to show people that. And there are lots of abstractions here in terms of how roles and privileges are assigned to objects and how you control those. Right, so you have a lot of flexibility with the full SQL style authorization in play, which can now allow you to control, although you're opening up the entire company's data, you can open it up in a very controlled fashion. And then the fourth piece, with the third is HCatalog, we talked at length about that. The fourth piece is Starling, which really gives us the insights, the historical insights into everything that goes on in the platform. And essentially what you would do is actually run an Oozie job, gather all the logs, machine logs from various clusters into one place and store it in HCatalog. So the raw files are in HDFS, metadata is in HCatalog. And then you can open that up as well for queries, right? So you can use Hive query, Discovery Portal can talk to it to do interesting stats, to do Lineage and other things. Or you can create other custom dashboards, whatever you may wish. Right, so as you can see, since we started this effort of consolidating that 1.25 billion files I talked to you about into HCatalog, the consumers, the ad hoc consumers that wanted to consume that data have really started to use SQL and Hadoop in a big way. And as you can see, the growth. So our job volume is also growing, but this is to neutralize that growth. In the last 1 year, we've gone from anywhere 13 million jobs a month to 26 million running now. But if you look at what's the SQL and Hadoop is doing, is just phenomenal. I mean, almost from nothing to about 2.5 million queries a month. And that dramatic growth was possible because of this approach. So everyone in the company is now trying to use data. And that's why we think this approach of HCatalog combined with data discovery really maximizes the value out of data for your company. So in summary, we talked about each of these challenges, and we described how our approach solves each of these challenges if you were a Hadoop-driven business, right? So, and all of this work is possible through a wonderful set of team that we have in the Hadoop Platforms group at Yahoo. So I want to acknowledge and thank them for making that graph possible. With that, we're going to open it up for questions. And I'll invite Thiruvul as well on stage. Anything you want to ask about Hadoop at Yahoo or our approach in general, you're welcome to. You have to come on the mic. Otherwise, no one will be able to hear it.
Hi. I think Thiru talked about the data discovery tool is something that you're planning to do.
That we're working on, yeah.
You're working on. So what's happening today? I mean,
in our company?
yeah.
So you have to log into each and every cluster's gateway, and you have to go to the command line, and you don't really have, you just have the Hive interface, so you just have to do a show tables.
So today you have a cluster level view versus a global view.
Okay, so you go to your cluster and then.
Yeah.
Who are the users that you're enabling with all of the Hadoop analytics?
I didn't get the question.
No, who are the users that you want to enable with this? Is there a set of users that are different than your regular users that you want to?
Oh, yeah. So if you think about the economy I described, we categorize a set of people as producers. Now, the producers are very, very savvy. Like, they really know Hadoop more than anybody else. It's the consumers downstream, analysts, reporting guys who struggle. And this approach really benefits them. Those set of users, like people in marketing department who want to figure out how many page views happened on Yahoo's posts on an ad hoc basis, can do this. Earlier, it wasn't possible for them. It's very hard for them to go tell and write a pig script or even map-reduce jobs. So they're the ones, the downstream consumers, those are the users who are really benefiting from this.
Hi there. So at eBay, we have tens of thousands of just entries in our Hive metastore of people just creating test tables and discarding them there. So I was wondering if what you guys do at Yahoo to ensure the quality of the metadata in HCatalog.
Yeah, so if you remember, Yahoo is a very old Hadoop shop, place, whatever you want to call it. We run our entire business on Hadoop. There's a lot of legacy behind the types of jobs that were written. There were streaming jobs, map-reduce jobs. Pig is still, as I showed you, a large proportion of that. So they never used Hive. And that's why HCatalog is important for us for a long period to come until everybody is comfortable with the metastore, all the data lands up in the metastore. That's one of the reasons why, for us, it's not just Hive, it's HCatalog, which is of primary importance.
Okay. And are you, I guess, do users create their own tables, or do you have administrators creating the metadata?
Do we have administration?
I'm sorry, I guess, who's tagging the data, right?
Who is registering the data?
Exactly, yeah.
It's the producers who are responsible in large sense. And we have tools, as we showed you, the GDM, the Grid Data Management tool that automatically, as it loads data, which it does today, primarily a lot of data, can automatically add partitions to the table that you want to create in HCatalog. So a lot of it is automated, but still there's a lot of work that producers have to do in terms of changing their pig scripts, changing their old code to work on the DB table and partition abstraction.
Okay. Thank you.
Hi there. Yeah. How do you do the data versioning? Is data lineage protection, all the stuff?
Yeah, I didn't really talk about the implementation. If you look at Lineage, there are different ways to do it. If you're doing it at a data level or even at a workflow level, you need to annotate each and every stage. Yeah. So we use Oozie and then Hadoop jobs, and in the middle you have Hive jobs, streaming jobs, and then pig jobs. So you have all sorts of stuff like that. So you take from who's a producer and you keep annotating your job configuration, and you can either do it real time, and you can use the Oozie information and do it in real time, or at least our approach is to do it after the fact. Right? Once you have all the job logs, I don't know if he touched upon Starling, which is a project that we mine and store all the logs, all the clusters logs together. Now we have one unified view to look at all the logs. So we did prototypes, and we were able to see the data flow across all the tables.
Who's doing the annotation? It's automatic, or?
No, you just add additional information to each and every job configuration, right? So if you add if you launch a Hive job, what is it writing to? Where is it reading from?
Okay.
And you can link them together.
Okay.
And you know what your query is. You can do stuff like that on top.
All right. Yeah. Thanks.
So I love the idea. I think it's a very real problem in terms of addressing technical metadata and data discovery across multiple clusters. But I'm also complementing his question. I'm very interested into the operational metadata, into the data lineage components of it. And with such a variety of transformation and movement tools inside the ecosystem, it becomes very hard to capture that transformation. So you can tell lineage and how the data sets interrelate. So in my architecture head, I've been thinking, well, you can probably design something with Oozie that can then put each one of those frameworks tied to it so you can try to capture the metadata there. And I just saw the Falcon Apache project right now, which is trying to address similar challenge. So, but I was also very interested into the last page, where you guys are trying to get all the log data. Can you elaborate a little bit more into how you're trying to plan to put together your data lineage story based on the logs?
Let's look at one approach, which is doing it after the fact, right? So if you look at the Starling slide that you saw, after every day you collect all the logs and you put it in one place, right? You get all the job history logs in one place. And on the other side, you also get all the queries that you ran from the job history files itself, right? Yeah. Now you also have the metadata from HCatalog, what the table schema is, and you have stuff like that. Now, if you look at each and every job, you know where it is reading from, where it is writing to. So by default, from job configuration, you can get map-read input dir, which is a job configuration that tells you where you read your data from, and map-read output dir, or an equivalent of that, which tells where you're writing your data to. That's only HDFS. So in a similar fashion, you start annotating the HCat loader, HCat storage, so that big use case is taken care of. If you're using HCat input format, HCat output format, the map-read use case is taken care of, and you annotate Hive with where you're reading your data from, where you're writing to it. So right now, Hive just parses the query in jobconf, right? Instead of just that basic information, once you start splitting that up, and then if you start writing it into what columns you're reading from, what tables you're reading from, and what tables you're writing to, right? Once you have that basic information, you just take them, and you can very possible to easily link them together. Yeah. Now, if your question is more like, once you take them, you definitely need something like a GraphDB so that it's much easier for you to play with it. But what information you have, what information you store there, all that, you get that over a period of time.
Got it. Thank you.
Yeah, the other part of the answer is that, so we don't have Falcon, right? And I think our approaches are quite similar in the sense that we have something called as GDM that I showed you that is quite automated with HCatalog. So if you take all that in play together with Hive and HCatalog itself, as well as the log history that we have, it's pretty easy to put that together.
Yeah. Thank you, guys.